Okay, when you read problem number 10, what is your thought as far as the strategy goes? Tree. So if you're going to do a tree, there have to be two things going on, and one has to depend on the other one. So what are the two things going on in the problem? Popcorn and soda. Does one depend on the other one?
Yes.
What depends on what? Soda depends on popcorn, right? You can tell me the numbers. So if soda depends on popcorn, what's going in the first level here? Popcorn. And then we'll have soda. Oh, this is no popcorn. So we'll have soda or no soda. Whoops. Now, what is the probability we're going to have popcorn?
90%.
Read the question. It tells you. What does it say?
2 out of 5. Yeah, 2 days of the week.
2 days of the week. How many days of the week are there if the school cafeteria is operating? 5. So what's the probability you're going to have popcorn? 40%. 2 out of 5. 40%. Which means the probability you won't have popcorn is 60%. Now, if you have popcorn, what's the probability you'll have soda? 90, which means there's a 10% chance you won't.
Right.
If you don't have popcorn, what's the probability you'll have soda?
45.
45, which means the probability you won't is 55. Now, we're not going to need all of these numbers, but I encouraged you to do these multiplications because as you do them, what did I say could be your check? All of these have to add up to what? You do not, in the problem, you're not going to need all of these, but I like to do them all just so I know if I'm right or not. The only numbers that I really need are the ones that answer the question. What was the question?
Find the probability that they would serve soda.
Okay, so I look at my diagram here, and here's a soda and here's a soda, right?
Mm-hmm.
So I take those probabilities, those soda probabilities, and what do I do with them?
Multiply.
No, I add them because, now listen, it's all tied to the words. I can have I can have soda 2 ways. I can have soda with popcorn, or I can have soda without popcorn. And when I say the word or, it's either this situation or it's this situation. Whenever I say the word or, what operation? Add. Right? Okay, who else had a question about one of the homework problems? Ethan.
11.
All right, what does 11 say? When you read number 11, you think Venn diagram. You should think Venn diagram, I should say. All right? So what's going on in the Venn diagram? We've got a couple of circles. What do our circles represent?
2 groups.
The 2 groups. And what are the 2 groups? Teaching and nursing. How many kids are in the pot here altogether?
60.
60? So there's 60 kids altogether. And I believe it says everybody loves one or the other.
Mm-hmm.
Yep. Okay. So how many like teaching?
40.
40. Now notice I'm writing that down here. I'm not putting 40 here because that 40 represents the whole ball. How many like nursing?
35.
35. Now think about this. Pretend that the 60 kids are in this room. Okay, there's 60 kids in this room. I say, raise your hand if you like teaching, and 40 hands go up. Okay, put your hands down. Now, raise your hand if you like nursing, and 35 hands go up. I have a problem. What's my problem?
Too many hands.
Too many hands. What does that mean? Too many hands went up. Which
on
means
the outside.
no. Some kids raise their hands twice, right? How many kids raise their hands twice? 15. There are 15 too many hands. That means 15 kids like both, which is fine. But the whole circle is 40. 15 of them are in this part of the circle, so there must be 25 in that part of the circle to give you a total of 40. Now, this whole circle is 35. So there must be 20 kids over there. Now, what do these add up to?
That adds up to about 45, 60.
Okay, there's none left over. Everybody, it's the problem set. Everybody is in the circles. Okay, so what's the question? This is not the answer. We need a
How many
question.
like nursing?
How many like only nursing?
Yes.
Only nursing would be 20. Okay, last one, number 9. Number 9, what's the probability of being dealt a 4-card hand? So it's a 4-card hand, and it's 2 queens. Okay, now first of all, it's a probability question. That means it will be a fraction, right? It's a 4-card hand. What will your denominator be? 52C4. Boys and girls, I'm going to say this one more time. Probability in the bottom goes the total. How many total cards are there in the deck? 52. How many total cards am I choosing? 4. That's why the denominator is 52C4. Now the numerator.
Would that be?
Now there's going to be 4 cards total. I have to pick 4 cards. And what do I know about the 4 cards I'm picking?
2 of them have to be.
2 of them have to be queens. Well, how many queens are there in the deck? 4. And I'm going to pick 2 of them. Don't stop there, though. Because how many cards are you supposed to have in your hand? 4. 2 of them are queens. What does that mean about the other 2? They're anything except queens. 48, C2. And those 2 numbers get multiplied. Why do those get multiplied? Because you have 2 queens and 2 other cards.
What if the question said at least 2 queens?
Then you would still have to do this problem because this is 2 queens. But then you would have to do a separate problem, structured just like that one, for 3 queens. And then you'd have to do a separate problem for 4 queens.
Okay.
So it would be like 3 of these problems. So you would get 3 individual answers. What would you do with those individual answers? Add them, because you are going to get 2 queens, or 3 queens, or 4 queens.
AKA, you would skip that problem.
Yeah, I regret asking that.
I'll look at it.
Okay, now I need you to get your note sheets out. And these are your same note sheets, your new note sheets. Oh, there's my sheet you want. Thank you. We are going to look on the back of page 61.
Oh, she's mud bound. Twin.
Okay, everybody on the back of page 61 in your note sheets now. Okay, here we go. Today we're going to start a conversation about arithmetic and geometric sequences. So right at the top, we're going to have a little like vocabulary section. You studied these last year. Does anybody remember what an arithmetic sequence is?
Numbers
Okay, it's a set of numbers.
in order
They're in order.
from
Is it an arranged set of
least to
numbers?
greatest.
Is it what?
An arranged set of numbers?
Well, that's a good start, but there's something special that makes it arithmetic versus geometric.
Oh, it's in order from least to greatest.
Nope, not necessarily.
Greatest
So
to-
let me give you a couple of examples. This is not the definition, but this is an example. An arithmetic sequence might be this set of numbers.
Oh, you have to guess what's next.
That's arithmetic.
Pattern.
Geometric might be this. Now, both of those have patterns.
Oh, you multiply by 3, not when you add by 4.
That's the difference. If you're adding to get from term to term, you're arithmetic. So an arithmetic sequence is a set of numbers in which you add the same thing to get from term to term. You add the same thing to get from term to term. So in this particular problem, we are adding 4, but we could pick a different number to add. To be arithmetic means you're a set of numbers where you add the same thing to get from term to term. What do you think geometric is then? Look at my example. We multiply by the same thing to get from term to term. The only difference between arithmetic and geometric is in arithmetic we add, and in geometric we multiply. Okay? Now, more vocabulary, squeeze it in here. The common difference is the number that you add to get from term to term. So go back, look at your definition. What's arithmetic? A set of numbers where you add the same number. That number that you add is called the common difference. So for our example, what would the common difference be?
4.
4. In a geometric sequence, we have a common ratio. What do you think the common ratio is?
That's 3.
The number that you multiply by. So for this example, it would be 3. So a geometric sequence, by definition, is a set of numbers where you get from term to term by multiplying by the same thing. The thing you multiply by is called the common ratio. In this example, it would be 3. Now, look at number 1, problem number 1. You're now going to look at these sets of numbers, and you're going to decide if they're arithmetic, geometric, or neither. If they're arithmetic or geometric, I want you to tell me the common difference or ratio, okay? So let's look at the first set of numbers. Can anybody see what's happening there? Jabron?
Divided by 2.
Okay. Dividing by 2, you're exactly right. What's another way of saying dividing by 2? Multiply by a half. So we're getting from term to term by timesing by a half, right? What does that make us, Thomas Berg? Arithmetic or geometric if we're timesing by a half?
Geometric.
Geometric. And if we're timesing by a half, our common ratio, and you can just say R, is a half. So the answer to A, geometric, R equals a half. Okay, B,
Add 10.
adding 10. If we are adding 10, does that make us arithmetic or geometric? Arithmetic. And what would our common difference be if we're adding 10? That would be 10. So you just write arithmetic, D equals 10. C,
Arithmetic. Added 10. Or adding 8.
Jabron says C is arithmetic and D equals 8. Is he right?
Yeah.
D, neither. Now, is there a pattern? Oh yeah, you should be able to see the pattern. Like if I said, what's the next term, you should be able to tell me. So I want you to think about that for a second. But you're not adding the same number to get from term to term. Would you agree? And you're not multiplying by the same number to get from term to term. So you are not arithmetic or geometric. That's a neither. Could you tell me, though, what the next term would be?
Yeah.
We get 22.
22? I don't think it's 22.
23.
It's 23. Why is it 23? Because in the first one we added 2, then we added 4, then we added 6, so it makes sense that we would then add 8. Perfect. E,
Geometric.
R2.
it's geometric because we are timesing by 2. So geometric, R equals 2. F, arithmetic, R equals 2, or D. We gotta use D if it's arithmetic, common difference. So arithmetic, D equals 2. Jack?
Can you have one that's just, it's like arithmetic, D equals like -2, like if you go,
Yep.
1, -1.
-3, -5, absolutely. D can be a negative number. It absolutely can. So can R.
Alright.
Okay, what about G?
I mean, they're getting squared, but it's not.
Okay, so it's not arithmetic and it's not geometric. Would everybody agree with that? But Patrick saw the pattern. And again, you should be able to see the pattern even if it's not arithmetic or geometric. What's our pattern?
3, 5, 7, 9.
Oh, that's a pattern. Hadn't thought of that one, but that's definitely a pattern. Patrick, what did you say?
What number are we on? Or what?
G?
G, oh, I thought the next one would be 36,
You're right, because why?
because 6 squared is
Exactly.
49.
Yeah, so I saw, when I looked at this sequence, I saw the squares. 1 squared, 2 squared, 3 squared, 4 squared, 5 squared. But Jabron saw, first I add 3, then I add 5,
That's the simple.
then I add 7, then I add 9, so then he would add 11 and he would get 36 also. Yeah, just a different way of looking at it and thinking about it. Okay?
Special.
All right, letter A. Does anybody have an idea? Okay, I've given this, I said B sub n equals 6 over n. All right, let's make sure we say that right. B sub n. B sub n. We don't say b to the n. We don't say bn. We say b sub n equals 6 over n. Now, take a wild guess. What do you think b sub 1 means? 6 over 1. Look, kids, isn't there an n here and an n here?
Yep.
So if you put a 1 in for that n, you have to put a 1 in for that n. So b sub 1 is 6. What's b sub 2? 6 over 2, which would be 3. What's b sub 3? 6 over 3, which is 2. How far am I going? B sub 4. 6 over 4, which is 3 halves, or 1.5 if you do it decimally. And then we want b sub 70, so that would be 6/70ths.
You just keep that?
Oh, so we can do that.
Okay,
That's a lot easier.
I think I understand this whole pre-calc.
All right, let's look at the next one. We have c sub n equal to 2n plus 1. So we want c sub 1. You are exactly right, Katie. It's going to be 2 times 1 plus 1, which is going to work out to be 3. And I want 2, 3, 4, and 70 again. Okay, so c sub 2 would be 2 times 2 plus 1, which is 5. 2 times 3 plus 1, which would be 7.
9,
2 times 4 plus 1, which would be 9.
141.
And 2 times 70 plus 1, which is 141. Very good. This sequence, look, 3, 5, 7, 9. What kind of sequence is this one? It's arithmetic with a common difference of 2. Everybody okay with that? Okay, because now things are starting to get interesting. Look at number 3. Even the directions are mind-boggling. For the following arithmetic sequences, find the common difference, the 8th term, and the explicit rule for the nth term.
I see a big jump between 3 and 2. Like an absurdly big jump.
So we need to
It's like
put
CYO to like the
and
NFL.
equation.
Wait,
Yep.
3 and 2.
It's literally like CYO to like the Indianapolis Colts.
Okay,
Way too.
so here we go. You can do this. I'm going to share with you something. Let's look at this set of numbers. And you could continue it, right? Because you see what's going on. What's going on in this set of numbers?
Subtract 4.
It's
We're
adding.
subtracting 4, which is adding -4. So this is arithmetic, and the common difference is -4. Right?
Yes.
Now, I want you not to write for a second. This is one of those times where I just want you to be paying attention. A sub 1 stands for the first term. This is the first term. So A sub 1 is 3. A sub 2 stands for the second term. And we got, I know what it is, but we got it by taking 3 plus -4. Isn't that how we got this number right here?
Yeah.
Now the third term we got by taking this one and adding another -4. That's how we got this number. We added -4 twice. So that's 3 plus 2 -4s. Now hang with me. Don't write this down, just pay attention. The next one came by adding yet another -4, right? So instead of adding 2 -4s, we actually added 3 -4s to get the next term. We added -4, -4, -4. Now hopefully you're noticing something. What's the relationship between the term number and the number of -4s that we end up adding? It's 1 less. So if you wanted the 8th term, it would be 3 plus 7 times -4.
Oh, that's a cheat
That
code.
holds true for all of them.
And that's gonna hold true for all of them. I'm gonna generalize it in a minute. But first of all, do you see that that's what's happening?
Yeah.
So your 8th term would be -25. Now, what you just discovered is a formula that I want you to write down and put a box and a star and highlight and everything else. For an arithmetic sequence, this only works with arithmetic. For an arithmetic sequence, the nth term, so whatever term you want, the 8th term, the 70th term, whatever, the nth term will always be the first term, whatever your first term is, plus the common difference times n minus 1. Now you discovered it for this problem. You figured that out all by yourselves on this problem. But this will work on every single arithmetic sequence. So if I said to you, what is the 100th term of this sequence? You would not be frightened. You would say 3, because that's the first term, plus 7, because that's our common, or no, excuse me, -4, because that's our common difference,
Yeah, it'll be 99.
and then it'd be 99, and minus 1.
That's not the same. Where's this n minus 1 though?
Yes, it is, that's the 99, that's 100, that's n,
Oh, that's
100 minus 1.
Okay, yeah.
So.
Now, for this sequence, write this formula for this sequence. That's what it means when it says write an explicit rule. It means write this formula for this sequence. So the nth term for this sequence, the nth term will be what? 3 plus, what's your common difference? -4 times n minus 1. So a sub n equals 3, your first term, plus -4, that's your common difference, times n minus 1. Now clean that up. Clean that equation up. Exactly. We're going to distribute. Oh, I don't know what you said. I don't know that what you said was right, but the idea is right. If I distribute, I'm going to get minus 4n plus 4. So I get 7 minus 4n. There's your explicit formula. And how did I get that again? Look over here. How did I get that again? 3. And then what did I do here? Distribute. And then I had like terms I could add together. So, not too bad. Let's try one more. B. So first thing you gotta do is kind of figure out what's going on. What's the common difference?
Add -1.
What are we doing to get from term to term here? Minusing 0.5, so that'll be -0.5. That's your common difference, -0.5. according to our formula, right here in the box that you have starred and highlighted, the 8th term will be what? The 8th term will be the first term. What's our first? Now wait, we're at a new problem. That formula doesn't work now. We're on a new problem. We're on B.
10.
What is our first term?
10.
10. What is our common difference? Negative 0.5. Now what is our n? If we're finding the 8th term, n is 8, which means n minus 1 is 7. So 10 plus negative 0.5 times 7. What does that equal? Okay, now, I know it looks different, the directions are wild and wacky, but kids, this is nothing but plugging and chugging. If you want the 8th term, you simply come over here and you plug that into your formula. So the 8th term will be the first term, which for this sequence is 10, plus the common difference, which for this sequence is negative 0.5. And if you're doing the 8th term, then n is 8. And n minus 1 would be 7. Now, what about a formula for this problem? Okay, well, what's our first term? Use that box as a model. What's your first term? 10. What's your common difference? Okay, so just simplify. That's all you have to do. Plug in your first term and your common difference and then simplify. So this will be 10 minus 0.5n plus 0.5?
Yes.
So a sub n equals 10.5 minus 0.5n.
Is that the answer for
That's for letter B.
A?
That's the a sub n. Yep. So this is the common difference. This is the work to get a sub n, or a sub 8, I mean, and this is what we do to get a sub n. Let's do this last one, then we'll have the arithmetic finished. Okay, so let's see if we can go through this now. Here we go, we're gonna answer the 3 questions that are asked. Question number 1. Oops, I don't wanna erase my formula. Question number 1 says, okay, look at this set of numbers. What's its common difference? 6. Okay, that's done. Now we want the 8th term. So you could just keep adding 6. I'm not going to do that. I'm going to use my formula. What does my formula tell me to do? To find the 8th term, I take the first term, which is 10, and I add the common difference, which is 6, times what? What's going to go in here? 7. Why is it 7? Because it's n minus 1, and n is 8. You made it 8. The problem made it 8. So did you say 52, Katie Baumgartner? Oh, no. Okay, well that would be the right answer, 52. Tim?
8 sub n is 10 plus 6 times 9 minus 1.
A sub n? That is what it would be right there. Yes, that would be correct. Now, we haven't simplified it yet, but for the explicit formula for a sub n, we just take what's in the box here, and we plug in our first term, and we plug in our common difference. And then we simplify by distributing. So your final answer would be 4 plus 6n, yeah. All right, I don't have my website updated after the testing change, so let me go ahead and just give you your homework now. And let me say it would be awesome if you did it. It would make my day.
Consider it done.
We're in section 9.4. I'll try to get my website updated today. We're in section 9.4, and we're doing 1 to 4, 21 to 24, but in this section, you're doing only A, B, and D, and then you're doing 29. So this is in section 9.4, we're doing 1 to 4, 21 to 24, only A, B, and D, and 29. Oh, and you want it. Thomas, can you turn that off?